Hello, Algebra students. Welcome back. We are going to do the lesson practice together at this point. And we're going to start off with some pretty easy problems. The first one, determine if each sequence is an arithmetic sequence. If yes, find the common difference and the next two terms. Okay, so if these are arithmetic sequences, what's going to happen is if I subtract the previous term from each term, I should get the same number. 6 minus 7 is negative 1. 5 minus 6 is negative 1. 4 minus 5 is negative 1. Yes, A is an arithmetic sequence. So I'm going to say A. The answer is arithmetic. And then we need to determine the common difference is negative 1. It's always the next term minus the previous term. 6 minus 7, 5 minus 6. So we're going to say D equals negative 1 because that's how we represent the common difference. And the next two terms are 3. Next terms are 3 and 2. Okay, letter B. 10, 12, 15, 19. Let's see, 12 minus 10 is 2, 15 minus 12 is 3, 19 minus 15 is 4. This is not arithmetic, so I don't have to do any of the other steps with it. It's not arithmetic because it doesn't have a common difference. It changes by different numbers each time. There's a sequence to it, there's a pattern to it, but it's not an arithmetic sequence. Letter C. Use a recursive formula to find the first four terms of an arithmetic sequence where A1 equals negative 3 and the common difference D equals 4. Okay, now here's the thing about this one. A recursive formula is a formula that changes slightly, but it changes according to a pattern. What we're not using yet is we're not using our formula for working these problems. We're using a recursive formula. Okay, so here's what we're going to do. The original term is negative 3, and we need to find the first four terms. So the first term is negative 3. Okay, the second term is going to be recursive formula. So I'm going to do negative 3. Let's see, and then the common difference, I have to add the common difference to this, so it's going to be plus 4, okay? So negative 3 plus 4 is 1. Now, I'm going to change my recursive formula, and it's going to be negative 3 plus 4 plus 4. Okay, I'm adding 4 twice. So the next term is going to be 5. And then the next term is going to be negative 3 plus 4 plus 4 plus 4. That's a recursive formula where we keep changing it by just adding one more number each time. That next one is going to be 9, and I have the first four terms of my arithmetic sequence. Note that A1 does count as one of the first four terms. All right, let's do letter D. Use the rule A sub n equals 14 plus n minus 1 times negative 3. Now remember, this actually is the formula for the nth term in an arithmetic sequence. 14 must be A1, and then the common difference is negative 3. Okay, so it says I'm going to use this formula to find the fourth and 11th terms. Well, what the fourth term, I'm going to plug in 4 for n. So to get the fourth term, A sub 4, A sub 4 is going to equal, let's see, 14 plus, let's see, this is the fourth term, so 4 minus 1 times the common difference, negative 3. So I'm taking my first term and I'm adding negative 3 to it 3 times. If I simplify this, it's going to be, let's see, I have to do order of operations, 4 minus 1. So it's going to be 14 plus 3 times negative 3, which is 14 plus negative 9. And then that's pretty easy to figure out. 14 plus negative 9. The fourth term of this equals 5, right? 14 plus negative 9 is 5. 14 plus negative 9 is the same as 14 minus 9. Now it tells me I need to find the 11th term. So I'm going to do A sub 11 equals. All right, the 11th term is going to be 14 plus 11 minus 1 times negative 3. I'm just going to do this one without writing out every single step here. 11 minus 1 is 10. 10 times negative 3 is negative 30. Ooh, 14 plus negative 30? That's going to be negative 16. 14 minus 30 is going to go negative. The difference between 14 and 30 is 16, and then I have to keep the negative sign because the negative number was bigger. All right, that's how we find those terms. So if I wrote out the whole sequence, and if I wanted to check myself, I'd start with 14, and then I would go down 3 each time. I would find that the 4th term is 5, and the 11th term is negative 16. Let's go on to letter E. Find the 10th term of the sequence, 1, 10, 19, 28. Okay, now, I could do this by just counting up terms. That's the cheating way to do this. Instead, what we're going to do is use the common difference formula. So we're going to do A sub 10, and then we're going to do equals. Let's see, so I need to write my first term. My first term is the number 1, plus, and then I'm looking for the 10th term, so it's going to be 10 minus 1, n minus 1, right? So 10 minus 1 times the common difference. 10 minus 1 is 9. 19 minus 10 is 9. 28 minus 19 is 9. So it's times 9. All right, so 10 minus 1 is 9. Times 9 is 81. 9 times 9 is 81. Plus 1. The 10th term of this sequence would be 82 from my common difference, from my formula for finding the nth term. I can do this for the 11th term of this next one. A to the 11th. All right, let's get this set up right. A to the 11th equals, it's going to be, oh man, now I have fractions. Can I even do this with fractions? As long as they are the same distance apart. 2/3, 1, 1 and 1/3, 1 and 2/3. Well, it seems like they're all 1/3 apart. So this is going to be the first term, 2/3 plus 11 minus 1, right? Because it has to be the nth term minus 1, times, and then we're going to multiply the common difference of 1/3. Okay, so let's just figure this out. 11 minus 1 is 10. 10 times 1/3 is 10/3, okay? 2/3 plus 10/3 is 12/3. 12/3 is 4. That means that the 11th term of this is going to be 4. And you could check me by starting at 2/3 and then counting up by 1/3 11 times to see if you get 4. But that equation works to find exactly that. All right, let's look at letter G. Flowers are purchased to put on tables at a reception. The head table needs to have 12 flowers, and the other tables need to have 6 flowers each. It sounds like I have an original amount of 12, and then I'm adding 6 each time. Write a rule to model this situation. Well, this is a pretty easy rule. It's going to be the nth term equals, and I'm just going to use my formula for an arithmetic sequence. The original amount, 12, plus, and then in parentheses, n minus 1, because I don't know what term I'm going to be looking for, times the common difference. The common difference here is 6, because each table that we add is going to have 6 more flowers. All right, so now letter H says that I'm supposed to use the rule to find A sub 15. So the 15th term in the sequence. Well, the original starting term is the same, 12, plus 15 minus 1 is 14 times 6. All right, we have to do a little thing here. 14 times 6, that's 6 times 10 plus 6 times 4. That's going to be 84. 84 plus 12 is 96. And that's how you do it. All right, you can now use the common difference along with the arithmetic sequence formula to figure out the nth term in any sequence. And I am going to expect that when problems come up, you're not just writing out the whole sequence and figuring out what the nth term is. I want to see this formula. You are going to be required to use this formula coming up. So when you come up on a lesson 34 problem, get ready to pull out this common difference formula and practice, 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 practice. Remember what I said at the beginning, we're making something that's relatively easy a little more complicated, but it's important to understand how to do this the more complicated way. Do lesson 34, numbers 1 through 30 for next time.